Okay, we're now recording. And let's see, try to share the screen. Uh-oh, it's not working. So let me try it again. I had problems with this earlier today also. Okay, I think we're good. All right, so I think I've settled on a final calendar. Welcome to May, which means we're almost done. Okay, I've already knocked off 12.1. All we have left are 12.2, 12.3, and 13.2. And I think I'll do the lecture this way. So we're going to do 12.2 today. Okay. So Thursday, I'll give you a quiz on 12.2. I decided to do this. We have two sections left, right? 12.3 and 13.2. I thought I would do half of each on Thursday and half of each on Tuesday. Okay, so in other words, instead of doing the usual, one day for this, one day for this, I'm going to do half of this and half of this on Thursday, the other half of this and this on Tuesday. That way you would have at least seen both of them. Okay. Now, if I did the regular schedule, then if I wait until Tuesday to lecture on 13.2, that leaves you with only 2 days to know the material before the test, right? So I thought I would do a half of this, so you've seen that, and half of this, so you've seen it. So at least you would have a week to see both material. See what I'm saying? All right. So today, only 12.2. The schedule's all messed up now, but 12.2. So both Thursday and Tuesday, it's 12.3 and 13.2. 12.3 and 13.2. Okay. Again, the reason for that is so that you wouldn't have seen 13.2 on Tuesday. Then you only have 2 days until the test. You would have at least seen both of those material. It wouldn't be brand new. It's fresh in your minds at least a little bit. Then I'll finish the rest of that on Tuesday. Okay. Then the last regular test is on Thursday, the 13th. Tuesday, 18th, we'll review for the final exam. So final review. And you might say, how do I study for the final exam? Just study off the old exams. Okay. And you've already got 4 of them, and you'll get the 5th one over here. Okay. And then, so again, Thursday, the 20th is our final exam, and then we're finished. So not review for final exam, that is our final exam. Okay. So that's where we are. Okay, so any general questions before we go ahead and start? Let me check the chat. I think there's nothing else in the chat. Okay, so 12.2, we're doing integration by substitution now. Okay, so we did integration. This whole chapter is pretty much integration. Now, the homework, 5 to 34, let me show it to you, but when you look at the numbers in my paper, they're different than what you see in the book. And like I said, it really doesn't matter because you don't have to do the evens anyway. So you're going to see all these numbers that are off by 2. I might say 6, but then it's actually 4. I might say 8, but it's actually 6, and so on. But it's just so you learn the material. But anyway, for those of you that don't have the book and weren't getting it, so here's 12.2, page 752. So we had 5 through 34 odd. So let me show that to you now. Not sure, I can't quite get you. Yeah, there we are. To raise the book up a little bit to get that. So the book's a little crooked now in order for me to show it to you, but I think you can read it all. And there we go. All right, so we're doing something called integration by substitution. It's basically the chain rule in reverse. Okay, so we know the chain rule. What do you mean by the chain rule in reverse? Okay, so here's the idea. Look for a function and its derivative or a constant times a derivative. Okay, I know it doesn't make any sense right now, but go ahead with it. We're looking for a function and its derivative, or maybe a constant times a derivative. We're going to let u be the function in general. It's called a U substitution. We're doing a U substitution. And then du equals the derivative of the function times dx. Okay. I know nothing still makes any sense right now, but as I do the second and the third and the fourth and the fifth example of these, hopefully as I do more and more problems, this will start to make some kind of sense. Okay, so integration by substitution. We look for a function and its derivative, or a constant times the derivative. So you don't have to see the function and its derivative, but maybe if I multiply it by a constant times the derivative, then I get it. Okay, we're gonna let u be the function. It's called a U substitution. Du equals the derivative of the function dx. Okay, now you recall we have du dx. We've used this before. It's called the Leibniz notation. Du dx is the same as the derivative of the function. If I multiply both sides by dx, dx cancels out, then it looks like this. Du equals derivative of the function dx. Okay, now some of you actually want to write this down. So I'll hold it, just for another minute or so. Okay, remember, you can always look back at the video for this. Okay, but you want to use this. And you say, should I put this on my cheat sheet? It's up to you. If you know the process, if you know what's going on, you don't really need to write it down. Okay, again, if we were meeting face to face, I'd make you memorize all this. Okay. And right now you might be absolutely lost and say, I don't have any idea what you're talking about. But maybe by the time I do the third or the fourth or the fifth one of these, then you might say, oh yeah, that's what he's talking about. So we look for a function and its derivative, or a constant times a derivative. We are doing the chain root in reverse. We're going to let u be the function, U substitution. Du is the derivative of the function dx. Okay. You don't really need this part here, but before one of the symbols for derivative was du dx. That's called the Leibniz notation. If we multiply both sides by dx, this side just becomes du. This becomes derivative dx. It's going to look like this in general. Okay, so the best way to show you how to do it is to get started with the homework problems. Okay, and then maybe some of this will make sense after a while. Okay, so problem 8, and I know this looks what I put 6 and 8, because in one version of the book, it was 8, and then another version of the book, it's 6. The version of the book that I just showed you, this is 6, but in the previous version, it was 8, but it doesn't matter, it's an even one anyway. Okay, so if you ignore the red temporarily, and that was my general standard for all these problems, when I put green or red, that wasn't the original problem. The original problem is what I have either in blue or black. So the original problem said integral 3x cubed plus 1 to the 4th power 9x squared dx. Okay, so ignore all the red temporarily. Okay, now look for a function and its derivative. So never mind about the or yet, that comes a little bit later. Do I see a function and its derivative in the problem? Okay, I see 3x cubed plus 1, right? What is the derivative of 3x cubed plus 1? 9x squared. And lo and behold, here it is, right? So one more time, the original problem was the integral of 3x cubed plus 1 to the 4th power, 9x squared dx. Okay, so we look for a function and its derivative. So let u be that function. So u is 3x cubed plus 1. Don't include the 4th power, just 3x cubed plus 1. And then it says du is the derivative of the function dx. So du is, what's the derivative of 3x cubed plus 1? So don't look at this yet. What's the derivative of 3x cubed plus 1? 9x squared dx. Okay, so this is the way we're normally going to write it. Okay, and getting back to this, we've seen this before, right? We said u equals 3x cubed plus 1, du dx equals 9x squared. Well, if you multiply both sides by dx, it now looks like this, right? Multiply this by dx, that cancels out. This is du, and this side becomes 9x squared dx. Okay, this says Leibniz notation. Okay, so one more time. Look for a function and its derivative. Okay, here's the function 3x cubed plus 1, whose derivative is 9x squared. Okay, a good guess is, okay, this is 3rd degree. The derivative of 3rd degree is going to be a 2nd degree, right? You know that. So a good way to guess is, okay, whichever has the higher exponent, that's the u, and then look for the derivative like this one to be that. Okay, now I do my substitution. So in the red circle here, I let that be u, right? So I have a much easier integral. Instead of 3x cubed plus 1 to the fourth, I have u to the fourth. Okay, so the substitution principle in math, whenever two things are equal, you can replace one with the other anytime you want. So instead of writing 3x cubed plus 1 to the fourth, I write u to the fourth. And then instead of this complicated 9x squared dx, I see that 9x squared dx is equal to du. So circled in red, that's u to the fourth. Circled in red, that's du. And look at how much easier this new integral is. Okay. And by the way, I will abbreviate I with the original integral. The original integral is I. That way I don't have to write the whole thing all over again. I will always mean the original integral. So alternatively, I could have written integral of 3x cubed plus 1 to the fourth 9x squared dx. Again, that's a waste of time. So my convention is I, capital I, is the original integral. All right, so it's u to the fourth du, and that's very easy. So let me finish the problem, and then we'll discuss it. So from the power root, u to the fifth over 5 plus c. And now just change u back to what it was. Okay, dividing by 5 is the same as multiplying by 1/5. So I decided to write it as 1/5. But if you leave it as divided by 5, that's okay. But 1/5. Now change u back. What was u? 3x cubed plus 1. So 3x cubed plus 1 to the fifth power plus c, final answer. So here we go. So I know there's a lot to digest. Let me run through the whole process again. Integration by substitution. It's the chain rule in reverse, okay, which means if you differentiate, you'll do the chain rule. So we look for a function and its derivative. I'll do the or later. Okay, the or will be harder problems. But for now, it's a function and its derivative. Okay, here's a function, 3x cubed plus 1. Here's the derivative, 9x squared, right? Let u be the function. It's a u substitution. So u equals 3x cubed plus 1. Du is the derivative of the function dx. So du is, what's the derivative of 3x cubed plus 1? 9x squared dx. All right, then I substitute. 3x cubed plus 1 to the fourth is now u to the fourth. 9x squared dx is now my du. And look at how much easier the new integral is when I change to the new variable u to the fourth du. And now you can kind of see what's going on with the dx and the du. Dx means the variable is x, du means the variable u. All right, integrate u to the fifth over 5 plus c. Then change u back. What was u? 3x cubed plus 1. So 1/5, 3x cubed plus 1 to the fifth power plus c. And check this out. From what we said last time, how can you check any derivative, any antiderivative problem? I gave the answer away, but how do you check any antiderivative, any integral? Take the derivative. Let's differentiate this. Differentiate means take the derivative. Okay, you know the derivative of any constant is 0, right? So take the derivative. 5 times 1/5, 1. 3x cubed plus 1 raised to the fourth power times by the chain rule, the derivative of the inside, which is 9x squared. Perfect. It works. So I know I have the right answer. Is that right? The derivative of this thing is this. So this was sort of what I mean by chain rule in reverse. Okay. That's what we're up against today. Okay, so let's just do more. Number 10 or 8, depends on which version you've got. The version that I gave you, I think this is problem 8. Yeah, that's right. Yeah, I originally put 10, that was the old version, but this is 8 now. Okay, so ignore the u's right now. 8x to the fourth plus 5 to the third power times 32x cubed dx. Okay, do you see a function and its derivative? And the hint is, look at the exponents. That's a 4, that's a 3. So you know by the power rule that if I take the derivative of a fourth power, there's going to be a third power. So probably this is going to be the u, and this is du, right? And it is. Let's check. Okay, what's the derivative of 8x to the fourth plus 5? 32x cubed. So there it is. Okay, so u equals 8x to the fourth plus 5. 32x cubed dx is du. Okay, 32x cubed dx is my du. Right? The derivative of this is this. Okay, so the next step, my I for integral, instead of writing this complicated stuff to the third power, I call it u. So it's u cubed, and then all of this 32x cubed dx, 32x cubed dx, pretend I erase it, get my eraser, change it to du. And look at how much easier that is now. All right, so u to the fourth over 4 plus c. I snuck in a 1 to make it 1/4, and then change u back. So what was u? 8x to the fourth plus 5. So final answer, 1/4, 8x to the fourth plus 5 raised to the fourth power plus c. Okay. Okay, question in the chat. Is the point of finding du to prove we can use a u sub? Somewhat. Okay. The relationship between du and dx is here. Du is 32x cubed times dx. Over here, du was equal to whatever it was, 9x squared dx. But it shows that we can do the substitution. And by the way, you can double check that this whole process works by taking the derivative and seeing if it works. Okay. Yeah, let's go ahead and check it. Okay, if this is the correct answer, the derivative of this should be this. Let's try it. What's the derivative of this? Okay, you already know the derivative of any constant is 0, right? So what's the derivative of this? 4 times 1/4, 1. So forget about that one. 8x to the fourth plus 5 raised to the third times the derivative of the inside, which is 32x cubed. Perfect. It works. Okay, question about the final exam again. So how do you study for the final exam? Study the old exams. Okay, so I will take some problems from each test. So let's pretend I give you, say, 3 questions, which I'm very much leaning towards something like that. So we're going to have 5 tests total, right? So maybe I'll take 3 questions from the first test, 3 questions from the second test, 3 from the third test, 3 from the fourth test, 3 from the fifth test. So I'll just look at each test and say, okay, I like that one, and that one. And then the second test, I like that one, and that's how I'll construct the final exam. So to study for the final exam, just study the old exams. Okay, you don't have to study everything. That's too much to study everything. Just study the old exams. Now, I'm not promising you I'll give you the very same questions, but maybe slight variations. But maybe I'll ask the same questions. So you can just use that to study for the final exam. Okay, so that's that. Okay, so I think I've caught up from the chat for now, and we'll keep going. Okay, 10 and 12. So integral of 4x squared minus 3x to the fourth times 8x minus 3 dx. Okay, so based on what we said, look over here. Look for a function and its derivative. So look at the original. Do you see a function and its derivative? Right? The derivative of 4x squared minus 3x, 8x minus 3. So function derivative, let u be the function. So which one's going to be my u? 4x squared minus 3x. And then the du, now here's the tricky thing. Don't let du be this automatically. Yes, it works for these examples, but that's not going to work in general. Just go ahead and take the derivative of this. So once you have this part, it's almost like you have to pretend this is not there anymore. Just ask yourself, what is the derivative of 4x squared minus 3x? Well, 8x minus 3. So du equals 8x minus 3 dx. Yes, for this problem, it happens to match. And yes, it happened to match here and also happened to match here. But the next problem, it isn't going to match exactly. Okay, so that's where I'm going to have to do the or here. So for the first 3 problems that I've shown you, look for a function and its derivative. But starting the next problem is going to get a little harder. That's when I'm going to do the OR part. Right, so function derivative. So let u be 4x squared minus 3x. If I don't look at this and I just independently said, what's the derivative of this? 8x minus 3 dx. And very nicely, it happens to match here. Very nicely, it happened to match here. And very nicely, it happened to match here. But starting the next problem, it isn't going to match exactly. All right, so my integral, I may have a choice. I can either write I or write all of this all over again. I don't think you want to write all of this all over again. I don't want to either. So let's make it convention. I will stand for the original integral. Okay, so instead of blah, blah, blah to the 4th power, u to the 4th power. I like it better. And instead of 8x minus 3 dx, 8x minus 3 dx, du. Okay, u to the 5th over 5 plus c. Change u back. So 1/5, what was u? 4x squared minus 3x. So 4x squared minus 3x to the 5th power plus c. And there's my answer. Double check the answer. If this is correct, right? Say, I wonder if I did this right. Take the derivative. If the derivative comes out to be this, you're good. So what's the derivative of this? 5 times 1/5, 1. 4x squared minus 3x raised to the 4th. Then by the chain root times the derivative of the inside, 8x minus 3. Perfect. So that's now what we mean by the chain root in reverse. Okay. All right, any questions, put it in the chat. Anybody join late, put your name in the chat so I can get, let me double check the chat every now and then. Okay, so anybody join late, put your name in the chat so I can get you for attendance. Okay, so now it gets a little harder. Okay, look for a function as derivative. Now we're doing the or a constant times the derivative. So what does that mean? Okay, 14. Okay, temporarily ignore all the green and the red that's there. Or I should say 12 or 14, depending on diversion. So 9x to the 5th, 3x to the 6th minus 4 to the 6th power dx. So which one should be my u? Big hint. That's a 5, that's a 6. So is the derivative of this probably going to be that? Or is the derivative of that probably going to be something like that? Right? Oh, this is 6th degree. The derivative of a 6th degree is going to be a 5th degree. Right? So let u be 3x to the 6th minus 4. Now, here's our first instance where I don't look at this anymore. U equals 3x to the 6 minus 4. Okay, that's a 6, that's a 5. I know the derivative of something with a 6 is going to be a 5. Now, what is the derivative of 3x to the 6 minus 4? Don't look at this anymore. What's the derivative of this? 18x to the 5th dx, right? Now, look back at the original. It was 9x to the 5th dx. I don't have 18x to the 5th dx, but that's where the or is. Or a constant times the derivative. I will get the derivative to match if I simply multiply inside by 2. Agreed? So one more time, I have 9x to the 5th dx. And by the way, it doesn't matter that they're not together. Multiplication is commutative. You can change the order anytime you want. So I can pick this up and put it in here if I wanted to. So again, I have 9x to the 5th dx. In order for me to substitute, I must have 18x to the 5th dx. How can I make it 18? I multiply by 2. But that's not fair unless I multiply outside by 1/2. So in red, I multiply by 1. And of course, in mathematics, if you multiply by 1, you don't change the value of an expression. So 1/2 outside, 2 inside, so I've multiplied by 1. And now everything that I have circled here in green, okay, I'll trace it out right now. That's 18x to the 5th dx. There's the 18, 9 times 2, 8x to the 5th. dx. So everything in green, pretend I erased that, I'm going to change it to du. This red, I'm going to change to u. So it's like I get my eraser, erase that, make it u to the 6. Get my eraser, everything within the green, erase that, erase that, erase that, make it du. So now my integral has a 1/2 out in front, u to the 6th, du. Du is 18x to the 5th dx. See, the original was 9x to the 5th dx. I'm not allowed to substitute until I see exactly 18x to the 5th dx. So I can get it if I multiply by 2, but in order to multiply by 2, I have to multiply by 1/2 outside. Now I have the requisite 18x to the 5th dx. So there we go. All right, so you look for a function and its derivative, or maybe a constant times the derivative. Okay, so 1/2 u to the 7th over 7 plus c. So this becomes 1/14, right? 1/14. And then change u back to what it was, 3x to the 6th minus 4 to the 7th power plus c. So that's my final answer now. Okay. All right, I won't do it this time, but if you take the derivative of this, you should get back the original. Okay, so I'll let you check that on your own if you wish. All right, 16 is a little bit weird. The original said 3, 5 minus x to the -3rd dx. (14) there, 3, look at 14, 3 parentheses 5 minus x to the -3rd dx. Okay, so what should I do? See, I don't like 5 minus x. I'd rather just let it be u. I like u to the -3rd. So here's what happens. You're allowed to take the 3 out, bring the 3 in front. Let u be 5 minus x. What is the derivative of 5 minus x? -1. Derivative 5 is 0, derivative of -x is -1. So du is -1 dx. So I need a -1 inside. So I simply put the -1 inside and a -1 outside. -1 times -1 is 1. Or you could say the reciprocal of -1 is also -1. Okay, so again, this 3 comes out. It joins a -1, so I'm going to have a -3 in front. -1 times dx, -1 dx, that's my du. And this 5 minus x is u. So I now have -3 times the integral of u to the -3 du. And now that's the way I want it. Okay, so power rule, -3 u to the -2 over -2 plus a constant. And -3 divided by -2 is a positive 3 over 2. Change u back. U was 5 minus x. So final answer, 3/5, 5 minus x to the -2 plus c. And the original problem had a negative exponent, so I'm allowed to leave the answer as a negative exponent. Okay. Otherwise, you'd have to put it into the denominator. And by the way, if you went ahead and put this in a denominator, I'll never mark you wrong. It'd be correct to still put the 5 minus x into the denominator, but otherwise, that pretty much does it. Okay. All right, so that's what we mean by look for a function and its derivative, easier case. That was the first 3 ones that I did. Or a constant times the derivative. So I don't quite see the derivative, but maybe if I multiply by a constant, a number, you're not allowed to multiply by a variable, but if I multiply by a constant, then I get the derivative. Okay. Okay. 18. Okay, what is the purpose of writing dx in the equation? Okay, dx just names the variable, but you can see when I put dx, after I do the substitution to du, it names what the substituting variable is. Okay, so it also tells you how du and dx are related. Okay, so when I switch over from dx to du, they're related by means of this formula. Du is -1 times dx, or du is 18x to the 5th dx. Okay, I know that probably doesn't answer your question, but it does tell you how they are related to each other. It goes much deeper into this if you were to take a formal calculus class. Okay, but du can be thought of as a very, very small change in u, and there's a very small change in x if you need a quick answer, which probably doesn't satisfy you much right now, but it does properly belong there. And the substitution won't work without having it there also. Okay. All right, 18. I've got so many lines all over 18 that I think I better show it to you. It's actually this book 16. Integral of 5x cubed and times 3x to the 4th plus 7 raised to the negative 4 dx. Okay. So I've got so much stuff in here, but I'm going to try to show you what the original was. The original was like this. Okay, so the integral symbol, 5x cubed, 3x to the 4th plus 7 to the negative 4 dx. Can you see a good candidate for u? Hint, that's a 4th power, that's a 3rd power. So this should be my u. Let u be 3x to the 4th plus 7. Okay, and now don't look at the rest of the original problem. Just say, what is the derivative of 3x to the 4th plus 7? My du, 12x cubed dx. Okay, so I need 12x cubed dx before I can substitute. Well, I have the x cubed. I don't have a 12, and I have a 5 that's kind of in the way. Just take the 5 outside. Okay, now I need a 12. So 12 inside, 1/12 outside. So in red, I've put in 1/12 times 12, which is 1. Perfect. So now out in front, I'm going to have a 5 times 1/12, 5/12. And then everything here, 12x cubed dx. 12x cubed dx. Get my eraser, erase that, du. 3x to the 4th plus 7, erase that, u. It becomes u to the negative 4th du. So out in front, I have a 1/12 times a 5, 5/12, integral of u to the minus 4 du. And there we go. All right, leave the 5/12 alone. Power root, u to the minus 3 over minus 3. So 5 over 12 times negative 3 is negative 536. Change u back. 3x to the 4th plus 7 raised to the negative 3rd plus c. The original problem had negative exponents. I can leave my answer with negative exponents. And there we go. Okay. Okay, moving right along. A few more problems. Okay, 18 or 20, depending on which version of the book you have. Two x cubed minus x to the 4th minus x squared, raised to the 6th power dx. Let's see, where is that here? Which problem was that? Yeah, it's the book's 18. 18. 2x cubed minus x to the 4th minus x squared to the 6th dx. This is higher, right? The derivative of the 4th power is going to be a 3rd power. So let this be u. Okay, u equals x to the 4th minus x squared. Du is, what's the derivative of x to the 4th? 4x cubed. What's the derivative of negative x squared? Negative 2x dx. Now, let's take a look at what they gave us. 2x cubed minus x. Well, I don't quite have this, but I'm close. How do you go from here to here? Multiply by 2. They gave me 2x cubed minus x. I need 4x cubed minus 2x. I can accomplish that if I multiply this by 2. So multiply by 2 inside, 1/2 outside. Now inside is indeed that times that. My two pens combined are 4x cubed minus 2x times dx. So that whole thing is now my du. That becomes my u. All right, so out in front for my I have 1/2. Instead of this messy thing to the 6th power, u to the 6th power. And instead of 2 times 2x cubed minus x dx, it's all du. All right, so that should pretty much do it. So 1/2 u to the 7th over 7 plus c. 1 over 2 times 7 is 1/14. Change u back to x to the 4th minus x squared to the 7th power plus c. Again, as a double check, you can convince yourself if you try to take the derivative of this, it should come back out to be that. I'll leave that to you as an exercise. Okay, I only have a couple more problems to do. We have plenty of time, so maybe I'll actually sneak in a little bit of where we're headed, and that'll just save me time next time in case something goes wrong or I get sick or my internet goes down or whatnot. Okay, maybe I'll even today just show you a little bit of what's going on with 12.3 and 13.2. Okay, since we have so much time, it looks like I think I can sneak that in. Okay, so your quiz next time will be stuff like this: substitution. Okay, now 26 is actually a little bit different. This one's different. X squared minus 5 squared, 2x squared. I don't see a function and its derivative anywhere. Right? Now, if this was just 2x, the derivative of x squared minus 5 is 2x, but it's 2x squared. That's no good. So how about a product rule? There is no product rule. All you can do for this one is just multiply it out. Okay, you just simply have to multiply it out. So that's how to do this one. So that's like a minus b squared. From algebra, that's a squared minus 2ab plus b squared. So x squared squared minus 2 times a times b. 2 times 5 is 10 times x squared plus b squared. 5 squared is 25. So x squared minus 5 squared, x squared minus 5 times x squared minus 5 is that. And then I distributed 2x squared. That's all. So that times that is 2x to the 6th. That times that is negative 20x to the 4th. And that times that is 50x squared dx. Okay, so now I just integrate that polynomial, which doesn't look that bad. Okay, so it's just power root. 2x to the 7th over 7 minus 20 x to the 5th over 5 plus 50 x cubed over 3 plus c. Let's see, I can reduce that, right? Minus 4. That's not reducible. That's irreducible. So final answer, 2/7 x to the 7th minus 4x to the 5th plus 50/3 x cubed plus c. And there we go. Okay, the last one I had was my 30, or it was this present book's 28. Cube root of x squared plus 2x times x plus 1 dx. Okay, so I'm finished after this. You can ask questions if you have any, but I think what I'll do is I'll at least show you, give you a little taste of what's left in the class, just in case I fall behind or something goes wrong. I'll show you what's happening with 12.3. I'll show you what's happening with 13.2. It'll save us some time for Thursday and Tuesday. Okay. So in the game plan, I'm just about done with what I was going to do today. I guess I've been marking these off. So we're here, right? 12.2. So next time, 12.3, 13.2, half of each. And then Tuesday, same thing, 12.3, 13.2. Exam 5, review for the final. And the 20th is the final exam, and then we're done. Right? All right, so ignore all the red stuff. Cube root, x squared plus 2x, x plus 1. All right, which one should be my u? This is second degree. This is first degree. You know the derivative of a second degree is probably first degree. So that u be all this stuff. So instead of cube root of a mess, it's just cube root of u. I like that better. So cover this up. U equals x squared plus 2x. What is the derivative of x squared plus 2x? Du is 2x plus 2 in parentheses dx. And by the way, once you add or subtract something, you're supposed to put parentheses. Okay, technically it's not correct if I leave off the parentheses. Then if I put dx, by order of operations, the dx would only apply to the 2, not to the whole thing, so it should be in parentheses. Okay, so I want 2x plus 2. What do they give me? X plus 1. Not a big deal. How do I go from x plus 1 to 2x plus 2? Multiply by 2. So in red, multiply by 2 inside and a half outside. So now when I do my U substitution, all of this, x squared plus 2x, is now u. So it's cube root of u. All of this, 2 times x plus 1, which is 2x plus 2, dx. Continue, erase it. It's du. And there we go. All right, so cube root means u to the 1/3. So 1/2 integral of u to the 1/3 du. Power root, add 1. What's 1 plus 1/3? 1 and 1/3, 4/3. Divided by 4/3, but we talked about this last time, right? If you divide by 4/3, you multiply by 3/4 plus a constant. And lastly, this comes out to be what? 3/8. Change u back to what it was, x squared plus 2x. So final answer, 3/8, x squared plus 2x to the 4/3 plus c. And that's it, and we're done. Okay, I'm finished, folks. If you want to ask questions, go ahead and put in the chat. Let me do my focusing thing, and I'll sneak in a little bit of what we have left. Give me this thing. Okay, and then the middle column. And then this column. And there we go. Okay. Okay, what is 12.3 about? It's still U substitution, but with exponential and log functions. Integrals involving exponential and log functions. So it's still going to be a U substitution. Okay. But I'll just give you a little taste of what's up. 12.3. If you look at number 1, 3e to the 3x dx. Number 1, do you see a function and its derivative? 3x has a derivative of 3. So same thing, except there's an exponential. So after you do a u substitution, you have e to the u, and you know the integral of e to the u is itself, e to the u plus c. That's all. Pretty much the same concept. How about look at number 9? X cubed e to the 3x to the 4th. If I let u be 3x to the 4th, what's the derivative of 3x to the 4th? 12x cubed. I don't have a 12. So think back to what we did today. Multiply inside by 12 and outside by 1/12. Okay, that's basically what's happening. That's 12.3. So we'll do that next time. Some of these are going to involve natural log, but you can kind of tell when it happens. 17. 17. Do you see a function as derivative? The derivative of the bottom is the top, is it not? X cubed plus 4. What's the derivative of x cubed plus 4? 3x squared. So u equals x cubed plus 4. Du equals 3x squared dx. That's 12.3. We'll do that next time, but it's still basically integration by substitution, except you're going to have exponential logs involved. Okay. The very last topic of the course, and then you're past Math 75, yay. Something called a definite integral in 13.2. Let me show you what it looks like. It kind of looks like stuff we've done before, except what do you notice is different? Like for number 1, see the integral 4x dx, they give you numbers 0 and 3, right? Or number 3, integral from 2 to 4 dx. Or number 7, integral from 0 to 5, or 17, negative 1 to 2, or whatever. Okay. Don't really panic. You still anti-differentiate, you still integrate. The only thing that's going to be different is after you integrate, you're going to plug in some numbers. What numbers do I plug in? The 2 numbers that you see there. So in some way, shape, or form, like for number 15, see the 2 and the 4, right? You're going to integrate, but you're going to plug in 4, and you're also going to be plugging in 2. And I'll show you how to do that next time. Okay, same for all of these. See how these integrals, they all give you numbers, right? Like 21. Integral of square root of 4x plus 9 dx, but there's numbers there, like 0 to 4 or whatever. You still integrate, anti-differentiate. You're going to be plugging in 4, and you're also going to be plugging in 0. Okay. So that's a little precursor of next time, and that is our entire course. Okay. All right, and let me check the chat. Okay, so yeah, anybody who came late, go ahead and put your name in the chat. What time does the final exam start? Okay, the final exam is exactly the same time as all the other dates. So 4:40 to 5:55. The entire time is for the final exam. So there's no question and answer session for the final. Any questions you would have to bring up on the day before. Okay. So right from the get-go, at 4:40 on Thursday the 20th, I will send through Canvas announcements, the final exam, or some of you who prefer to have it projected here, I can do that also, if anybody wants it that way. So any questions would have to be on our final review day, which is on the 18th. Okay. All right, and let's see, Kyle, I got you here. Din, I got you, and Jesse, I got you. And I think I got everybody else there. Okay. All right, any other questions, please? Otherwise, we're done for the day. And they've given you a little taste of what's left. Okay, so Thursday, I'll do some of 12.3, some of 13.2, and the quiz will be on stuff that we had today on the U substitution. And likewise, next Tuesday, I'll just finish up the part that I didn't do for 12.3 and 13.2, and also leave time for a question and answer session if you have any questions. And then we take the test on next Thursday. Okay, anything else? Otherwise, we're done for today, folks. Wait just a moment. Okay, all right. I don't see or hear anything else, so we're going to call it a day. All right, that's it for today, folks. Everybody have a good evening, and we'll see you next time.
Thank you.
Bye, everybody.
Thank you.
Thank you. Good night.